Whether it is generating unpredictable outcomes, creating diverse gameplay elements, or simulating realistic environments, random numbers form the foundation of countless game mechanics. Today you will learn about all random properties and methods in Unity, and I will show you all the tools you need in order to succeed. Let's start with the most obvious one, Random.Range. You probably used it already, so in brief, Random.Range has two variants. The float overload just returns a random float value within range. Both the lower and upper bounds are inclusive, meaning that the function can generate whatever is between them, and of course values itself. And speaking of values, there also exists something called Random.Value. It is the same thing as Random.Range 0 to 1, but it is shorter, I guess. Anyway, there are endless uses of values this small. My favorite, which is not so obvious, is combining it with the power of evaluate. The random value passed to the animation curve will be treated like a horizontal position, so for example this has a greater chance of generating lower numbers, as it is shallower at the beginning, and this will make values close to the extremes more common. For numbers without decimal point, use the same function but with int overload. It works pretty much the same as float, but it returns an integer value within range. Also, the max value is exclusive, so for example Random.Range 0 to 10 will return a value between 0 and 9, each with approximately equal chance. Random.InsideUnitCircle or InsideUnitSphere returns a point inside or on a circle with radius 1 as a vector. There are endless uses of this function, for example anything in random direction, loot spawning in random position, or spawning something around the player. You can of course normalize and multiply this vector to achieve various distances. For some strange reason, there only exists pre-normalized version for 3D. It is called Random..onUnitSphere, but you can achieve the same thing by normalizing the vector from previous functions. Random.Rotation. Congratulations, you guessed it! It just returns a random rotation. There are no overloads, so you can't easily specify boundaries. There also exists Random.Rotation Uniform that uses a better algorithm, but it is slower and for geeks. Random.ColorHSV. It is just random color with overloads such as hues, saturation values and alpha. Now we have to slow down for a little while. I will tell you a story. When I was a kid, I loved to play Minecraft. I created many servers. I think this is what sparked my love for game dev. But I always wondered, how can Minecraft remember all the words it generates without taking up huge amounts of space? I watched countless videos explaining how Minecraft world is as big as planet Neptune. But how can millions of cubic meters be stored just as a simple number? The answer lies in the nature of generating random numbers by computer. Think about a random number between 0 and 10. Great! Now form the formula to achieve it. You can't? That's because it isn't possible. The random number generator isn't truly random. It follows a specific pattern that just seems random. That is why we call it a pseudo-random number generator. We use a seed value to start this pattern at a different point. You can choose your own seed to create the same one when needed. For example, in a game you can use random elements to make the game look natural, but set the seed to generate each once each time. This saves storage and time, since you only need to store the seed value for each level. The seed is randomly set at startup, but if you want to change it or randomize it later on, you can use Random.InitState. Once you set the seed, you can't get it back. The pseudo-randomization algorithm keeps its internal state in a complicated set of numbers. But you can save and load the state using the state property. It works with a special type called state that can be saved and loaded. In the future I will show you how to use seed to the utmost by creating random level generator.